Good afternoon, everyone. Thanks for being here. I will talk about service mesh and service mesh at ING. 180 million requests have been flowing through ING service mesh today already, and by the end of this talk, another 90 million have been executed. About 10,000 instances in the production environment fulfill the customer's needs. And to give you a bit more sense of the scale that we operate at, I have here a slide with some facts. So ING is a bank. We operate at the global scale in over 40 countries. We serve about 40 million customers, and 10,000 or more than 10,000 are working in IT or in tech. And these people together provide a superior customer experience. My name is Jens Kat, and I'm responsible for the development, support, and rollout of ING Service Mesh that these 1,800 services use. So today I want to share with you how we grew a service mesh, what it is, and how it started 8 years ago. I want to tell a story how we got there. I will describe what a service mesh is, and then I will have a look at what we do at ING with what we call the 3 planes. Now it might not make sense to you, but it will be at the end, and then there will be a wrap-up. So let's dive in. So let me take you back to ING about 10 years ago, but this is probably also applicable to other companies. So you have a business and you have your customers that do use your business in an online environment. Now in your company, you have developers. They start developing, they have applications, or one application, multiple applications, and you have multiple teams working together on that application. Now, with this single application, it has been called out already today, the monolith. You have a single application doing many things, and some features have to wait for other features to finalize, to finish before you can put it live. And with the going live, you also can run into issues that one of the things doesn't really work as you expect. You roll back the full application with all the new features that you promised to your users. Your velocity goes down, your developer frustration goes up, your customer satisfaction goes down. So you say something has to change. You need to untangle the monolith and you want to split it up in separate domains. And you do this by introducing smaller services that split this large application into smaller contained applications. And you start communicating within these services using APIs. So you decouple the dependencies in your domain, and you can now release at your own pace. You can scale out based on customer demand, and you can satisfy your customers in a better way. So you start adopting the microservices architecture. Now with this adoption, you also run into something that you say, my hardware or where these instances are running becomes more dynamic. I don't have server A, server B, and if server A something goes wrong on that server, you log in, you make it healthy again, and this is where the analogy pets versus cattle comes in. Say, if the server doesn't work or I want to scale out, you just pull out new instances in the cloud, private or public, and everything is working as you want. This also adds another aspect that your instances are more dynamic, and with this dynamic changes, you make it harder for yourself to connect in the production environment. So you say, I need to overcome this fact. I need to have something in place that I can now, at runtime, dynamically discover my instances that can scale out and scale down. And you need a supporting infrastructure for this. So you want to know, where do these apps live? And this is where service discovery comes in, which I draw as a small database underneath. So the application can now dynamically look for active instances and then figure out, I can now connect to these instances, so my production traffic is uninterrupted. So you dynamically can find instances that belong to a cluster, and with this, we glance over maybe a thing that is given, but everything is going over the network. And in the network, we say this is insecure, so we need to have security between these services calling out. Typically, what you see is that you do this using TLS, Transport Layer Security, and your application and the application you call will need to provide their identities both to each other. And this is called mutual TLS. So the client has a identity certificate, and your server has an identity certificate. And both can now verify that they are who they say they are. Now, all the apps can find each other in a secure way, but we still have an issue. So with MTLS, we have authentication in place, but we have a very important thing that sometimes you don't want everyone to call a specific server, and this is where authorization comes in place. So in this example, we have a service that acts or has two features. One is generate a report, and the other one is launch rockets. And you don't want to have anyone with a valid or valid authentication to call the launch rockets functionality. So you want to lock this down. You need to have a means that says if you don't have the proper authorization, you're not allowed to call this endpoint. So with authorization, we need, we know that only authorized users can connect to the features that you open up. And while you build out your microservices architecture, you keep adding requirements, you keep adding design decisions, and then, for example, where do we keep these subscriptions? How are they managed? How do we do this stuff at scale? And with all these technical concerns, we kind of emerge, or out of these design decisions, a service mesh emerges. And the definition that I would like to use is a mesh of services. A service mesh takes care of the technical integration. So the service-to-service communication forms a application-level network, and it does things like name resolution, load balancing, and the security part. And what you typically, what you typically see in a service mesh implementation is that you have something called a library or a sidecar that is performing this very specific functionality for the applications that run in the production environment. So at ING, we have a service mesh, and that didn't happen overnight. We have been building this in the past 8 years. First, I was a developer working mostly on the lower part, the data plane, and later also working on the control plane. Nowadays, I'm the technical product owner and a developer of both the control plane and the data plane, which is the service mesh. So what we just described can be captured in so-called planes. And we have one called the control plane. This is where service discovery, for example, lives, that controls the workloads in production. And this control plane, it's called a plane because it's not in the same realm as your data, as your business traffic. And the data plane, this is where the actual requests, the user requests, customers' requests are flowing through. And it's very important that this control plane is not in the way. So if the control plane is unavailable, this does not interrupt the business request flow. So the data plane can run without an active control plane for as long as your environment is stable. Now we skip over a very important thing, and that is where do we put and manage all the subscriptions and the APIs that we introduced when we went with the microservices. And this is where we at ING have something called the governance plane. And the governance plane typically in an organization is called the developer portal or the API marketplace. And this facilitates this is the place where we put all the APIs and we put all the subscriptions between producers, providers, and consumers in a single registry. Now, the data from the governance plane goes down to the control plane. The control plane knows who can call who, and the control plane and the data plane interact with each other. So the data plane, if both governance plane and control plane are not available, that does not, and it's very important to understand, there is no service interruption if that's the case. Right, so with the governance plane, I want to start there. So we have a marketplace, and the API marketplace is a place where we allow developers, business, but also IT people to design and explore APIs. So maybe back in the days, you could walk to another desk, say, hey, I see you are building functionality that I need to use for offering my functionality. Maybe you did that through mail. Maybe you have your documentation in Confluence or on a wiki, but that doesn't scale. So at ING Scale, we are active in, or the developers are active in about 15 countries. And we see that we need to have a more mature solution than mailing each other outdated information. So this is what the API marketplace facilitates. It is a place where you upload your OpenAPI specification, and it is a place where people, developers, can look for already offered APIs. By having this centrally in place, we also foster reuse. So if you have your, let's say, accounts API designed in the Netherlands, you also, and you want to offer the same functionality in Spain, for example, you can already look for the same API definition, say, this is what I also want to offer, and start implementing that API. The third thing the API marketplace does is it facilitates the communication between producers and consumers. So you API owner offer functionality, and you want, or people want to start using that functionality. So you want to have a talk with your consumers, say, okay, what amount of TPS do you expect here? When do you want to go live? Things like that. So you can do some forecasting of capacity. And you also centrally manage who is allowed to call what functionality of your API. And by having this in place, it is clear for the provider who their consumers are. So it's not randomly all of a sudden that new parties start consuming you. That's the authorization part. And with the implementation part, we also have in place that the providers can only implement or offer services that they actually own. So you cannot mimic or make typos somewhere that say, okay, I'm now the accounts API, but I'm not the owner of the account API. So then how is this subscription being transferred as runtime? And this is where we use, so this is the consumer and the producer. And the consumer then gets from this API marketplace, the registry, it gets the proof that the governance plane says you are allowed to consume this specific endpoint. And this proof, the subscription, is then put on every request. And every request, and this allows the producer to start validating the incoming request. So do you have a token that says you are allowed to call my this specific endpoint? And this makes, and by having it set up in this way, we make sure that the consumer is driving the usage of this feature. So this allows the producer to not go live, say, oh, I have to update my ACL, my access control list, and there's a new service going live. I need to go live first before they can start calling us. Now, this is now completely decoupled, and the consumer can just provide this token. It's a JSON Web Token in our case, that contains the proof from the governance plane that this communication is allowed. Now, this has a cost, of course. The tokens that we issue or are being issued by the API marketplace have a lifetime. So it's harder, by having a lifetime, it's harder to revoke these tokens. However, we are in ING, in the production environment, in a safe space, so it's not for third parties and things like that. And the other cost is that this is adding bytes to a request. And this has to be present on every request. And I think the trade-off here is you can do this autonomous, or you could have like an oracle that says you're allowed to call this or not allowed to call this, and you have to make API calls to verify if something can go through or not. Now, in our environment, so an API, maybe I stepped a bit over that. The Open API specification is a bunch of endpoints. And in the API marketplace, we allow teams to subscribe per endpoint. So if you have the account API and you offer 5 endpoints, you can just subscribe to one API, one endpoint. This means that this mechanism or this decoupling makes it easy for producers to scale up specific functionality. Say, oh, I need more reads, or my reads need to scale up, or my writes need to scale up, scale out. And this is where the consumers at runtime are only interested in endpoints to look up. So we don't have the account service. You just look up this specific endpoint that happens to be implemented by a specific service. Now, this is where API endpoint discovery comes in. Instead of service discovery, we do this on API endpoint level. It's an in-house built product. And you can think of, as I tried to explain, you can think of API endpoint discovery as service discovery, where one endpoint is implemented in one service. So for the sake of this talk, I think it's easier to then talk about service discovery. It's that functionality that it offers. So service discovery in our environment is like the phone book. So you start looking up where do the latest and the latest instances that I need to fulfill my feature, where do they run? And this is basically translating a endpoint into a DNS. The workloads that run in our environment do first announce themselves in the service discovery solution. So they start up, they announce which endpoints they are serving, so we can map the instances to endpoints. And then they start sending so-called heartbeats. So every couple of seconds, they start sending, I'm still here, I'm still here. Now, the consumers in the mesh can then query the service discovery and get back a list of fresh, up-to-date information. Now, next to this endpoint to DNS translation, it also offers other runtime configuration. For example, we have waits for enabling traffic management in service mesh. So you can steer away traffic from a specific region to another region, or allow canary releasing by shifting the weights in such a way that your traffic is distributed in the mesh given those weights. And this is all the role of API endpoint discovery. So then the third plane, the data plane. We started adopting this microservices architecture. We have already seen that security is a must-have. So with security, we've gone over the authentication part, where we use mutual TLS, where the client and the server can validate that they say who they say they are using TLS certificates. And we have seen the authorization implementation that we have, where we use JSON Web Tokens to unlock or to enable consumption in the production environment. Now, another very important thing when you run at a specific scale, also in the case of monoliths, but for microservices even more, is to have observability. And with observability, I mean the three pillars, metrics, logging, and tracing. So your workloads run at different locations. They are ephemeral, and you want to know, are they healthy or not? So you need to have insights in how this workload is actually running. This is where metrics come in. So your metrics are shipped to a data lake where you can do correlation, can put in alerts, are the requests coming in, what is the response time, things like that. You also want to know what the inner workings of your app are doing. Maybe you have some error statements, or you handle error situations, and you want to know that that is happening. You also need your logging to be shipped to a data lake. Maybe in the old times you could log into the machine, grab through the log for a specific line. Nowadays, you want this to be shipped to a central location because of the scale and the ephemeral workloads that you have. In the microservices architecture, you started using APIs to offer functionality. You split up the domains, and now you also want to have insights in what function call or what hop in the call chain is going wrong. And this is where distributed tracing comes in. With distributed tracing, you make sure that you get insights in how your workloads are calling each other, how long it takes, to what node or what instance it ended up. And if something goes wrong, you can immediately pinpoint what instance was unhealthy, was timing out, things like that. So you open up your production environment and you get insights in what is happening at the runtime. Then probably the first thing you see is that calls will fail. There will be timeouts. There will be anomalies that you can't explain. And this is where the resiliency part also comes in. Your microservices architecture has to be resilient to errors. You want to provide the best customer experience, and you start adopting, or you need at least to have a couple of things in place. One of them that we use is client-side load balancing. So the clients get their information from API endpoint discovery, and the clients make the decision which node or which instance is fastest, is most healthy, can serve my traffic. So this is up to the client. And you want to start using timeouts, maybe adopt a retry strategy. That you don't wait indefinitely for an answer if it never comes. You want to say, let's wait 5 seconds, let's wait 100 milliseconds. And with retries, you can then start allowing multiple calls for the same action in case one of the earlier calls failed. Now, there's a bunch more of resiliency that you can do, but security, observability, and resiliency are must-haves in the data plane when you operate at a specific scale. So we have seen that the governance plane allows the developers to reuse API specifications, to implement them and subscribe to them. We also have seen that the control plane allows us to have the relevant information available at all time. And the data plane is where we have the observability, resiliency, and security. Now, if you start saying this is what you need to do to your business teams, there will be some riot, or maybe they're very happy, but these concerns are typically not what you expect to be part of your business applications. And if you start handing out these requirements to 100 teams or to 500 teams, you will get 500 different implementations, or maybe in the end the implementations adhere to the requirements, but it's a waste that is then imposed on all those business teams to start adopting your requirements that you have in place. So this is where we in ING have come up with the factor out the common parts of the service mesh. So we have a library. This is based on Spring Boot. And this library allows our Java developers or JVM developers to easily, or by adopting this library, using it, they know that they adhere to the requirements that we have in place. Next to that, we have a sidecar. And the sidecar is a process, a proxy, that runs next to your business application. And the sidecar's only purpose is to take care of this technical integration with other services. Integrate with the control plane and integrate in a resilient, observable, secure way with the other workloads. Now, both have their own use case. And the library makes sense if you have a homogeneous landscape of languages. So in our case, that's the JVM. Sidecar makes it easier if you have a polyglot environment where you don't want to have separate libraries per programming language because there's overhead. And currently we offer both in the ING. Now, when we started out a couple of years ago, it turned out that you can have something out there, but you also need to know how to start using it. So this is where the documentation came in. So you can write a README in a repository, but that's not good enough. And that's well, let's say it doesn't scale. So we invested in writing proper documentation. And with the help of technical writers, we are able to reach all the developers that use our applications and framework. And we make sure that they start adopting and using the features that we offer in the intended way and are aware of the features that we offer. When you have your application or your framework out there, soon you realize that everything that is out there is part of your public interface. So we've seen some talks about keep your interface small, and we also learned that lesson. So the moment you put your library out, you forget that something was public or at least available through a property, people will start use that. And that makes it very hard. And maybe if you have 3 teams, 5 teams using it, you can just go there and say, hey, please stop using it. We don't intend to expose this property, or we want to retire it. But if you are using 1,500 or 2,000 workloads, that is a serious problem. And this is where we have introduced something called insights in our application. And the insights basically is a dump of the runtime configuration, where we then can do some data analysis on, we expose many properties, but then we can see, is anyone actually using the property that we want to change or want to retire, or are people using, for example, request timeouts in a way that we do not expect, like timing out on 1 hour instead of 1 second. And then we can have a discussion, say, what are you trying to achieve, and is this the best way to achieve it? Next to that, when you have your own stuff out there, we are a single team supporting these libraries and this application. If you want to go fast, go alone, they say. But if you want to go far, go together. And this is where we are building a community around the products that we deliver and support. And by having these communities in place, or one community, or more enabled teams in other parts of ING, we make sure that the products are used in the right way, and that if there are signals from one of those teams that have issues or troubles, that can reach us again. So it's our means to have a, let's say, bidirectional communication channel, instead of only pushing out new releases or news items, things like that. So having a community is really important to us. Now, if you operate at a scale, you start seeing that teams are running into the same issues. For us, we started out, like I said, 8 years ago. And we imposed the MTLS requirement on them. And MTLS, or TLS certificates, needed to be requested manually. At that time, I looked it up, the ACME protocol was, I think, standardized in 2016, so around the same time, but it was not available to us yet. So ACME is the automatic certificate management environment, I think. So for example, teams had to request certificates for their own workloads. Well, this is a burden, a toil. So in the progress of adopting the service mesh and putting restrictions in place, hurting developers if they wanted to use our stuff, we worked on making certificates or requesting certificates in an automated way. The same is what we did for trust stores. So remember the governance plane had the authority that handles the implementations and the subscriptions. These are also signed tokens. I skipped over that bit, but these tokens are signed, and then the producer can verify that it's coming from this trusted authority, and those certificates also rotate. So nowadays we distribute this trust store in a JSON web key set to the workloads in production, so that we take away these manual processes for the teams to say, oh, you use the service mesh, but you also have to do things in a manual way. We also have automated, for example, the subscriptions. If you do a deployment, you make sure that you fetch the latest and up-to-date subscriptions, inject them in your runtime, and make sure that everything keeps working in production. I think there was also a talk on the Maven archetype or Spring Initializer. We also have that. To also bootstrap your pipeline, make sure that your project layout is adhering to what we think are the standards. But a very important one is the automation of disaster recovery or the disaster recovery tests. How often, how do you know that your backup is working? Well, you have to do a backup and restore test, and we have the same. So we say we are resilient to disasters. Well, you have to prove that in, of course, the production environment. So you do a disaster recovery test. And by having this control plane, we can now shift the traffic away from a specific region and make sure that everything keeps working, or shift it back and restore everything. And this is now done in an automated fashion. So we don't overload the teams by saying, are you resilient for disasters? We can take the burden away from them, say, yeah, you are, because you are part of our service mesh. So there's a lot of moving parts in the service mesh. We know that the only constant in our sector, in IT, is change. And every year, new requirements, new technologies pop up. And we need to, or we want to, stay up to date with our service mesh. We try to use the analogy to swap the plane engine and keep it flying. At some point, you just have to keep up to date with what is out there. For example, sidecars in the community have been coming up, like Linkerd, Envoy sidecar. Control planes have been popping up since we started doing our own stuff, ASTO or Linkerd or Kuma. And we want to, we are not married to the stuff we do. I think in IT, it's important to use best practices and get rid of what you built. So, okay, and the community does it better, or this product is better. And we have that same mindset. So we are looking into the best practices out there, but we needed to have some validation in place. Okay, we currently have something that works for us. We want to keep it working, or at least we know we have lots of services using it in that specific way. So we can't just pull out the current implementation and replace it with something entirely new. There has to be a grace period. We need to be sure that we can bridge the migration period. And this is where a tool comes in that we have developed, and this is capturing our service mesh behavior. So if you have your service mesh, like I showed in the beginning, so I need mutual TLS, I need authorization in place, distributed tracing, you can kind of write it down like a acceptance test or an integration test. Say, if I have an application and I start it and I start sending a request to it, then I expect it, then it should accept handshakes for TLS 1.2, or it should reject TLS handshakes in 1.3 with a specific cipher because it's unsupported or it's deemed insecure. If a token is on the request, you need to validate it. So we can create all these kinds of assertions of the application, of the sidecar, of the framework. And by having those assertions in place, like a regression test suite, we can start replacing the implementation. So this is a very powerful tool for us, and we're currently actually replacing the in-house built sidecar with the Envoy sidecar. And this tool is really relevant for us to see what comes out of the box or what we need to tweak to make the migration seamless. Now, I want to give one more takeaway. So I think in an organization, the service mesh is an abstraction. And the analogy I like to use is, do you know how your network card works? With error detection or correction, traffic control, data conversion, whatever it does. So yeah, I don't need this for my day-to-day operations. I just want to browse the internet, right? So you can know how it works. Yeah? Documentation is out there. You can dive into drivers, the hardware even. And this is how I like to see the service mesh, or at least the service mesh as ING. It's a great abstraction. And to aid that abstraction for the users, we inject the sidecars automatically at runtime. We make sure that they are available as a managed package on virtual machines. So if there are updates, it can be a seamless update. And the platform team that I'm part of take care of the details, support the offering, and make sure that the service mesh is used in its best way. Now, that wraps up the talk. So, what have we seen? The service mesh is a great abstraction that lets the application teams focus on building business applications, but it's not a free abstraction. A lot of things have to be in place, have to be maintained to make sure that your production environment benefits from the best practices. The library and the sidecar have their own target audiences. When to use them depends on the use case, and it has its own trade-offs. You can relieve your teams by automating certain processes, maybe not all of them, just where it makes sense, so that teams can focus and keep working on delivering business value. And the last one that I want to give away is the capturing or the codifying of your mesh requirements in a tool, in a regression test that lets you evolve your mesh implementation with confidence. Now, I guess about the 90 million requests have been handled by all the instances in our service mesh. And I haven't been called, so that's a great success. Thank you very much. Please rate the talk in the app. Would be much appreciated. Follow us and have a pleasant DevOps. Are there any questions? Thank you. Yeah. No more questions. Yeah, here.
Yeah, I have two questions. The first, very simple. Did you try to evaluate the standard solutions for service mesh, like Istio, and what is basically many people already use the first one? And the second question, a little bit danger. Of course, it makes a lot of sense to use service mesh, especially in the large landscape as you have. Big danger is that the people tend to put more and more functionality inside the service mesh and finally put some business logic inside. Do you have such kind of cases and how you deal with that?
Yeah, great question. Thanks. So 2 questions. The first question was, did you look at or are you looking at, let's say, standards in the terms of service mesh? And the second question was, are people in the organization or teams putting more business functionality in the service mesh? So let's start with the first one. Yes, we are looking at off-the-shelf solutions, and indeed, one of them, one of the default control planes is Istio. When we started 8 years ago, that was not there, or at least not in the form that it currently is. We have been evaluating that 3 years ago. Let's be honest. And at that time, the requirements we have with virtual machines, multi-region, and Kubernetes clusters were not met by the tool called Istio, the control plane. However, we were attracted by the sidecar implementation, Envoy, and this is where we started looking and adopting the Envoy sidecar. So we did pick and choose and adopt part of it. And then the second one, the business functionality into the service mesh layer. Yes, it is. Let's say it might be tempting to indeed put business functionality in, like maybe even XML to JSON conversion or things that you say, well, that does not belong in the technical layer. And yeah, there are requests in the company, but yeah, we are strict on indeed making it allow them to do that in their own app, right? But not pull that functionality in the service mesh. The service mesh is a clean, it's only technical concerns, so we make sure that we can also evolve and we don't dig this hole into, and we cannot use any solution out there in the market because we are very special. So we try to stay away from that. Yeah, thanks. Yeah, question there.
Thank you for the talk. How do you handle the situation when two services want to communicate not by API calls, but by messages?
All right, so the question is, how do you handle not API calls in the service mesh, but through messages? In our case, it is indeed an API landscape. So we do all the communication through APIs. However, there are also message buses or event buses. That is there, but it's not managed by our control plane, which is fully on the HTTP side. Yeah. Any more questions? Oh, sorry. Yeah, over there.
Regarding the internal market space for APIs and so on, do you go so far that you include intra-company billing to serve the APIs to other partners?
So the question is, with the API marketplace, do we have or include billing internally to other parts of the company? Billing is not in place. So the TPS or the load, that's the expected load, is in place, but we don't bill this with internal euros or stuff like that. No, that's not there. Thanks. Anything else? Okay. Well, thank you very much for your attention, and I wish you a pleasant DevOps. Thank you.
initialize Genesis sequence.